Alright, so what do we got here? Oh boy, we got some different stuff. Look at this. Look at that fuse, guys. That's a totally different fuse than what we're used to. That is a nice high quality fuse, a proper one, not any of those cheap automotive fuses. It's 80 amps. This is a 48 volt inverter. Okay. Get some wires. And I'm going to pause this video for a second, right before I get this out. Okay, so this is how it showed up out of the box. It's in some plastic. Help keep the humidity and stuff off. I'll take that out. It's got 4 plugs on the front. That is awfully nice. Not very many inverters have 4 plugs. I believe it's because this is a split phase, low frequency. So it's got essentially 1500 watts coming to these plugs and 1500 watts coming to these plugs. And then you get 240, 3000 watts here, or 2 1500 watt legs. Line 1, line 2. And of course it's got surge because it's a low frequency inverter. We'll be testing this. This is pretty cool. And I'll be testing this in conjunction with... Okay, I'll be testing this with this 60 amp MPPT charge controller from Reliable as well. Here's your specs on it. To show everything. Yep, that shows just about everything. So we're going to make ourselves a solar powered system, completely powered by Reliable here. Reliable Electric. And look at that. They even have the universal plug style here. I wonder if that's 240 volts. I'm going to have to test that. That would be very interesting. But if it was, it could also destroy your stuff. So it must be 120. Yeah, you got a ground plug there. You got... This thing's a little heavy, but... Looks like you got your positive, negative. You got some nice white fans here. You got a massive heat sink in there. I don't know if you guys can see it in between the fan blades, but then you got this this lug here. I'm not sure what this does. I have to look into it. I'm guessing possibly ground, maybe. I'm not sure, but I have to read the manual. Let's see what this thing says in the back. This is a 48 volt inverter. 12240. It's a split phase. That's awesome. 60 hertz. And all of Reliable's information on it. Call and figure things out with them if you have to. Now, it's not super heavy. It's probably, I'd say like, I don't know, 30, 35 pounds, something like that. That would be my guess. I would actually guess more like 25 to 35 pounds, something like that. And yeah. Got some plastic to remove. Ooh, it's nice. Anyways, let's get this thing hooked up. Real quick before we hook this up, let's take a look inside. Okay, I've had a few minutes to look around, and so far this is looking pretty good. This is like full try-hard. This might be one of the better designs I've seen for high frequency inverters, at least the ones I've looked at. So this is still high frequency. You got your input stage feeding this massive transformer, 3000 watt transformer. You have your output stage, which are 250 volt caps here. You got your nice proper 80 amp fuse in the front. You got your line 1, line 2 current sensors. You got 3 massive chokes. You have, let's see here. Looks like these are input FETs. Oh, not, sorry, input capacitors there. What do we got? And then you just got some filters. Line 1 and line 2 filters, most likely, is what this is. Yeah, no, pretty happy with this so far. These look a little thin, but I got to do the math to see if they'd be able to take the current of 3000 watts. I believe they would at 48 volts. They look like 10 gauge, I believe. Yeah, something like that. 10 gauge, and then this one looks like a 6 gauge. Now they do everything in millimeter. So, oh, maybe 5 gauge. Is that what that is? 5 gauge. No, this one I can't see what they are. Yeah. Anyways, let's get this thing back together. Actually, one more thing I want to show you guys. So this plug is on line 1. This plug is on line 2. And this plug here is 240. If you check where all the wires go, this one goes to here. And this one goes to there. Yep, this is 240. But the thing is, you got to be careful. This will take a 120 outlet. Because this can take them all. This can take 240, it can take 120. Don't plug a 120 device into here. But I mean, if you have a plug and you wanted to get 240 for something, you could do it, but yeah, you got to be careful. This is line 1, neutral, line 2, ground. Okay, so we're just about to set up this inverter, and this inverter has a nice feature. It has a resistor. So it's got the 2 positives. One's for the main hookup, and the other one is for the resistor to pre-charge the capacitor, so you don't get that massive spark, and sometimes it blows off traces inside. There's just a tiny little spark. We're pre-charged, and you go and you connect it to your main positive, and that's it. That's the only job this little positive has, and it's really nice. Okay, we got the first turn on of this inverter. Let's see what happens here. We got power. Get the screen on. It's a pretty nice little screen. There we go. We have 58.3 volts on the batteries. The fan's turned on for a second. You get 119 volts per leg and 239 on the main leg, the 240 side. Awesome. Now we got to give this thing a test. Okay, we're going to try this little heater now. This is a 1500 watt heater. This is 3000 watt inverter. It's got 1500 watts per leg, but I believe I can do a little bit more per leg, but I'm not sure. We're going to find out anyways. Let's see what happens if we... Is this touchscreen? I don't know what this does. Oh, it is. Okay. Interesting. I'm not sure how to do everything, but here, let's turn this on. Okay, we're on 1500 watts. It shows the load right here. And it's on this leg only. 10.5 amps, 11 amps, 11.2 amps. Sorry about that. Look at that. We got a 1500 watt load on here. I don't know if you guys can hear it. It is on. Okay, so that's running just fine. We've dropped down to 57 volts. The fans are on. The fans are very quiet. This is their quietest inverter by far. Anyways. Okay, that's pretty cool. Well, it runs a 1500 watt inverter. Let's get another one, put it on the other leg. Okay, so that's been running the whole time. Oh, look at that. It was already on. Okay, well, we know it works. Let's see what it looks like when we actually turn this thing on. I'm going to turn it to high. See what the screen says. Turned it on. Look at that. We're running two 50 and 100 watt heaters. It's drooped to 117 volts, which is just fine. That's completely fine still. This is now maxing this inverter out. Well, it says it can do 12.2 amp or 12.5 amps per leg. We are a little under that, but it seems to be running just fine. I'm using the provided cables that it came with. Look at that. Wow, that's really good. Pretty happy with that. That's just a quick test, and there you have it. That is Reliable's new 3000 watt inverter. Still powering 3000 watts worth of load, approximately. Two 1500 watt inverter or heaters, and it's doing really, really well. That's awesome. Even gives you a temperature. I wonder if that's on the inside of the inverter. All right. So we just finished testing the reliable 3000 watt split phase 240 and 120 volt inverter. That is pretty much marketed towards North America, which we have split phase 240 and 120. This is 60 hertz, and it seems to be working really well. I don't know what kind of options we have for the screen here. Status is normal. I guess you have yourself, maybe once it has some codes, you can click the codes and whatnot. You can click that little thing in the corner and it gives you some information. Anyways, it's a quick video. The next video we're going to make is going to have this 60 amp charge controller. We're going to pair this. We're going to make a system between the inverter and this charge controller. And this inverter is still running 3000 watts, by the way. I just kept it going this whole time. Seems to be doing good. Oh, batteries are having a hard time though. Alright, I better stop this test. At least take this one off. Battery started dropping real quick. And then this one. See what the batteries bounce back to. Cabling's all good. Guess the batteries are just having a hard time. Anyways, hope you guys enjoyed this little test. There'll be many to come. I'm going to try powering my entire house with this thing and see how it does. See if we can take the surge loads of the fridges, the freezers. I got 4 fridges plugged in and 2 full-size chest freezers, soon to be 3. And we'll see how this thing can handle it. I'm not going to try and run everything in the house. Obviously, you're limited to 3000 watts, but I'm looking for lights, refrigeration. It's not going to do my well pump. My well pump takes way too much power for this thing, but you can get lower rated well pumps. Mine's just for a high rate of flow. And yeah, we'll try running the house. Now, bonus footage. No going off grid video is complete without doing an overload test. Got to do an overload test. So I'm doing an overload test on just one leg, because that's most likely what you're going to do, is overload just the one side of the inverter. You're most likely not going to overload the whole thing. You still might if you put a lot of things on here. This is your terminal block. This is where you can get your 120 on each leg and your 240. I gotta look up what does what. There's a nice manual that comes with it. Anyways, we're gonna turn on this 1500 watt heater and then that one onto low, and that should put us way over 12.5 amps per leg. And we're gonna go and see how it handles it. Okay, so here we go. We're gonna turn this one on. That is on. It's producing heat. I'll turn the temperature down just so you can see it is in fact on. Fans turned on the inverter. There is our load, 11.2 amps. Now I'm going to turn this one on low. Put it right up here. And this is fan. And let's go to low. We got a warning, 16.6 amps. Wow, it's running it. We have an alarm though. And then it shut off. Well, it has a good surge though. Wow. Okay. So wait, what will happen now? Okay. So you got an overload status. Everything shut down. I want to see if it comes back on. I haven't read the manual to see if it does or not, but okay. Oh. Okay, so it looks like you got to cycle it to turn it back on, which I kind of like because you're never going to get a brownout condition like this. Turn it back on, make sure everything is off. Okay, we're good. And we're working again. Look at that. Just make sure everything works still. Turn the heater on. Fans turn on. Everything seems like it's working fine. Awesome. Well, at least you do get a nice surge, because essentially you get 1500 watts per leg. 1500 watts at 120, 1500 watts at 120, 3000 watts at 240. But you get a surge at 120, which is quite nice. I really like that. Now the surge was, I think, what is that? I think that's 750. So we had 1500 watts plus 750. So it was a little over 2000 watts we're pulling from just one leg, which is more than what these receptacles can handle anyways. These technically, actually, these are a 20 amp rated plug. So actually they can handle it. That's good. So that's pretty cool. I actually kind of really like this inverter. I like the fact that it's 240. And paired with their charge controller, I'm going to make a little system out of this, and we're going to see how it runs. Just an introductory, guys. Hope you enjoyed the video.